So, I had the assets market description, and that's also a very good description. It's not a very elaborate description. The crucial assumption there that we used, if you remember, was that the rate of interest and the prices of assets are inversely related, non-money assets are inversely related. Whether it's true in an economy, who knows? Suppose you go back to early days, like even 10, 15 years, 20 years back in the Indian economy, interest rates were all very regulated. So, stock market prices and interest rates were never related, because they were regulated interest rates. RBI was putting a restriction on interest rates, and banks didn't have the freedom to increase or decrease them. Now, we are entering a regime where interest rates are set free. So, banks they are deregulating them. Deregulating them means they are saying, okay, we are not going to put any restriction outside. Banks, you decide what interest rate is going to be, what you want to charge. So, in a system now, it's very funny, you probably have different banks having different interest rates. Earlier, when I was growing up, any bank you go to, particularly public sector banks were there, private sector banks hardly we knew. There were no Citibank, no Standard Chartered, no Hong Kong Bank, no Deutsche Bank, nothing. I have never seen them before. I saw them only a few years back. So, any public sector bank you go to, government bank, which were all nationalized in India in 1969, Allahabad Bank, Punjab National Bank, State Bank of India, Canara Bank, Bank of Baroda. Funny thing was, any bank you go to is a public sector bank, is more or less the same interest rate, or if not exactly the same interest rate you will get. So, why do different banks exist, you wonder? Actually, their origin was different. The origin was different. They were all in the private sector. They were nationalized and they remained a separate entity. They were initially, before nationalization, they were private sector banks. Anyway, so it's debatable, but we need not go into that. We are into macroeconomic theory, understanding it. If macroeconomic theory fails to explain something, some of the assumptions that we are making are not realistic, we will have to take note of that at the time of discussing that particular issue. Say about Indian economy, now interest rates are regulated. Well, ho gaya, LM function invalid. You cannot have an LM function like that, at least you cannot connect it with the stock market. Then the model becomes more deficient. All right? Okay. And if you have interest rates regulated, what would happen? ISLM model, you can have excess supply, excess demand situations. You may not have an equilibrium point. If you are regulating it, controlling it, it's not a free variable, then it cannot correct the imbalance. And like a demand supply function may not intersect. The price may be at a place where the demand is more or the supply is more, because you have fixed it. It doesn't change. Same thing will happen in ISLM model. If interest rates are regulated, they will get fixed. You have permanent disequilibrium. It cannot correct and go to the intersection of ISLM. So, these issues are there, but we did not worry about it because we want to learn the macroeconomic theory. Now, in the ISLM model yesterday, I was doing something, one more theoretical exercise I will do before I go into those multipliers, etc., is that I was trying to talk about now in this simultaneous equation system that you have, we have two equations, and the x and y variables that have to be solved are output and interest rate. You know simultaneous equations, right? It's no big deal, you know that. So, the two equations will solve for the values of rate of interest and output, and those will be the equilibrium values. The question is, if you are in a disequilibrium zone, like the zone 1, zone 2, zone 3, zone 4, then you have various kinds of disequilibrium. Goods market disequilibrium is one type, maybe excess supply, but money market may be excess demand. All right. In another case, the goods market has excess demand and the money market has excess supply. So, you have a whole lot of combination of disequilibrium. So, with what we call a phase diagram, I was trying to find out that given the assumption that whenever there is a goods market disequilibrium, output will adjust y, and whenever there is a money market disequilibrium, the rate of interest will adjust to clear the money market. If we make that assumption, that rate of interest responds to any disequilibrium in the money market and output responds to any disequilibrium in the goods market, all right, then we get those arrows. Horizontal arrows were showing y adjustment, vertical arrows were showing rate of interest adjustments. Now, when two variables are adjusting, suppose there is a disequilibrium in both the markets, then the combination of the two will be the final impact on the economy. So, I had an oscillating path assuming it reaches equilibrium over time, all right. But the economy really does not go through an oscillation like that. Economy usually goes through a disequilibrium adjustment, as I was trying to tell you, on kind of a one line, non-linear line maybe, passing through the equilibrium point, it goes and catches that line and comes down a ladder or goes up the ladder. It does not keep on oscillating. It remains within one zone after it gets sold of that equilibrium path and then goes up and down to reach the point, intersecting point. Now, algebraically, we can also talk about this stability. These are called stability issues. The stability of the model, we can also talk about algebraically. Now, in microeconomics, what we do as opposed to macroeconomics, in microeconomics, we say a company is maximizing profit, good. But we obtain algebraically the first order conditions. For an optimum, the tangent will be zero slope. A curve has reached an optimum, the tangent there will be zero slope. So, that tangent is called in algebraic terms is the first derivative, z equal to 0. But whether it has reached a maximum or it has reached a minimum, we put the second order conditions. The second order conditions for a maximum would say, if you have reached the maximum, beyond that point the curve should be coming down. And for a minimum, if you have reached the minimum, then beyond that point the curve should be climbing up. So, in terms of second derivatives, you have negative second derivative less than 0 for a maximum, and for a minimum you have positive. Now, these second order conditions, parallel issues, these are also called stability issues in microeconomics. The parallel issues in macroeconomics are these stability conditions. That if you reach an equilibrium, whether it is stable or not, you know if you are dislodged from the equilibrium, whether you can come back to it or not. Like I have a toy which has a spring attached to it. I shoot it, but then I want it to become, I want that to return to me, all right. Then I call it equilibrium. It's disequilibrium if you shoot it and it keeps on flying out, like in space. You throw something, it goes into some other orbit. So, that's disequilibrium. In differential equation systems, if you have done mathematics, what you have is, you have three kinds of paths that you can get from differential equations when they talk about stability issues. One is an oscillating path, keeps on going up and down around the equilibrium point, never reaches it. Oscillating path, continuously, same amplitude. Mathematics में differential equation पढ़ाते हैं to talk about the equilibriums, all right. One can be an oscillating path, one can be a converging path. That means the differences go down and reach an equilibrium point, and one can be a diverging path, which is an exploding. The cycles, if you talk about kind of a cycles or whatever, path to equilibrium, one can be converging, one can be diverging, and one can be oscillating. Oscillating one and the diverging are ruled out for stability purposes, only the converging path. So, the question is, as soon as you have in the ISLM model a disequilibrium, what will happen? Point is, if there is a shock to the system, you're thrown out. Do you come back? Or you reach a new equilibrium point. These are the two issues. Suppose the IS curve shifts. Graphically, I know, sir, the intersecting point is there, that's the equilibrium point. Well, that's very easy to say. It's like a first order condition. But do we reach that? All right? So is there a path to reach that? Now, suppose I say there is a shock to the system. Say you are at a point A. Now, at point A, you have disequilibrium. You have some output in the economy, say a demand, Y naught, but output is at some equilibrium value, say YE. Now, if the demand shifts for some reason, there is an economy which can say that you have reached a point where you have some sort of a disequilibrium. So, whether you return to the equilibrium point or not. All right? So, the companies would say, suppose the companies are saying, oh, this is the point we actually are producing. All right? But the IS curve has the demand in it, and the demand is here, not here. So, what the companies would do, companies would reduce output. So, what you have here is that you require a movement in this direction. All right? Alternatively, I can say, suppose the IS curve has shifted. So, output is here, but demand has gone there or somewhere. For overall equilibrium, you need the intersecting point. So, does the economy travel from this point to this point? Either way, if the IS curve shifts because of increase in demand, I was talking about G increases, then suppose the IS curve shifts to some point, and you know graphically this is the equilibrium point. What has happened is the demand has shifted there. That's why IS has shifted. So, the companies are producing at YE, but the demand is somewhere in between. Suppose not in between, somewhere here. So, the question is whether the companies would produce more, number one, and whether you would reach here, which requires a rate of interest adjustment, whether rate of interest also climbs up to this point. Two adjustments are required. Then you reach the new equilibrium point. If you don't, if there is any shock, the economy goes out to somewhere here, then here. It's far away from the equilibrium point. That's an unstable situation. Now, this kind of stability issues are like second order conditions in macroeconomics, similar to microeconomics. And in simple terms, suppose you have one variable y, forget about rate of interest now. Suppose one variable y, what will happen if demand curve shifts or the economy was here, which I was trying to explain earlier. So, it is more they are producing than what the demand is. Now, the demand is here, but the economy is producing here. It will reduce supply. Or if IS shifts because of demand increases, then output should increase to a new equilibrium point here, and rate of interest also will increase. Now, in case of one variable, if you look at one variable, you are saying if there is a disequilibrium, as soon as y is not equal to d, there is a y dot. There exists a y dot. Y would change. There exists a y dot. Output would change. Okay? Companies would start revising their production plans. Unintended inventory changes I was talking about, which would signal them change the output level. So, they would change output. The question is, if that y dot, the change in output, y dot is what? dy over dt, that's y dot. If output changes, if you find over time as becoming smaller and smaller, that means the companies are realizing that and making the extra output smaller and smaller means what? They are reaching an equilibrium point. They can see the market is getting happy, saturated, satisfied. But if companies have a reaction where output changes are becoming larger and larger, they are getting the wrong signal. A market cannot be an ever expanding market. If the output changes over time, if you find becoming larger and larger, you have some sort of a disequilibrium in the situation. Why it is there, we don't know. But the companies are responding by increasing output bigger and bigger. But I know I have to go there. What happens in a car? You start the car, you start at a slow speed, then you go to the second gear, third gear. When the road is smooth, the traffic is not, they go to fourth gear and you travel. As you see you're approaching the destination, then what happens from that steady speed, you start lowering it to third gear, then second gear, finally you reach the destination one gear. The speed slows down, mean you're reaching the destination. But if some lunatic is there who wants to go from distance A to B, cannot see B, instead of slowing it down or reaching a steady speed at some point, it keeps on increasing the speed, doesn't come down from the fourth gear. So from 80 kilometers go to 100 kilometers, 120 kilometers, it will overshoot the equilibrium and go out. And if he doesn't see more, if there is some more barrier, he may just crash. There will be an accident. That's unstable path. In case of a stable path, the change in output of course will be there, because there is a shock to the system. Either demand has gone up or they were producing more as like A, so they should come down. All right, disequilibrium output they were producing, so they should lower it. Or if demand shifts like I shift, then they would increase output. But if the increase in output becomes through knowledge, through learning, how market adjusts, becomes, if you see firms are getting more confident in increasing, but slowing it down, increase. No need to panic. We can see the destination, how much we have to increase for the market to remain satisfied. That means the market has a stable path to an equilibrium. You understand what I'm saying? So the y dot term will be there, non-zero. But the question is whether dy dot is less than 0 or not. The change in y dot becomes smaller and smaller or not. Do you see that? What I'm saying? Y dot will be non-zero. As soon as y is not equal to z, this y dot will be non-zero, not equal to 0. And then when y dot becomes 0, means dy dot has to become negative, smaller and smaller and smaller and smaller, then finally y dot is 0. No change in output, further change in output is required. Because we reach the equilibrium, so y is at the new equilibrium value, matches the demand, no more requirement to change the output, so y dot is 0. No more change in output. Do you understand? So in case of one variable, I can talk about the stability issue simply in terms of these y dot and dy dot variable. Is the intuition clear? Is the intuition clear? Anybody has a problem? No problem. But the problem is, in this model you just don't have one variable which would respond or react to a disequilibrium. You have R also. So now we will have two dynamic variables. At the equilibrium point, R dot will also be 0. It has reached equilibrium. No more change is required. Y dot is also 0. But at some point, R dot and Y dot both may be non-zero. Like phase 1, phase 2, phase 3, phase 4, with those arrows I was showing. R is changing, Y is changing. So both can change. In this case, the algebra becomes a little bit more complicated. And I don't want to give you an algebraic proof, but I want you to accept, if you want references where to get the proof of this kind of a thing, I can also keep something at copy point if any of you interested in the mathematics of it. What happens is, then I need to work with two dynamic variables, y dot, r dot, where I will get a matrix. And the stability conditions are the properties of that matrix. So I impose some conditions on that matrix. Now just not y dot, when you have two variables. So can I just explain that to you, how that matrix is used a little bit? Please don't ask me. Where is the theoretical proof that this is the stability condition in case of two variables adjusting? Well, I can show that to you. I have some algebraic proof. I can keep that at copy point. I can give you references, but it will unnecessarily take up time. In fact, I have forgotten to prove it. I have to open the book and prove the theorem. It's like a theorem. So I'm going to use the theorem. In case of two variables, it's simple. You have 2 by 2 matrix you will have. And in case of 2 by 2 matrix, what you have, the determinant will be positive and the trace will be negative. That's all. In case of one variable, it will be one element, one component of that matrix which has to be negative. dy dot dy has to be negative essentially there. But in case of two variables, it will be, you have understood dy dot negative. Why did I say that? The change in y dot becomes smaller and smaller. You're approaching equilibrium, converging path. And in case of 2 by 2 matrix, 2 by 2 because of two variables, it will have 2 by 2 matrix. It will be the determinant of the matrix is positive, the trace is negative. That's what it will be. So what I would do now, I would use the ISLM model. I'm talking about the ISLM model. I've used the assumptions that we already have and try to find out whether the ISLM model ensures that a matrix like that has a determinant positive and trace negative or not. If it is true, don't ask me why the determinant positive and trace negative required. I required the theorem to be proved. Please don't ask me. I can give you some reference to that where it's available. It's not very difficult. You require differential equations to solve it. That's all. So let me go back to the hypothesis we had. Yes?
So by decreasing y dot, are we not creating a case of recession?
No, 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 no. Change in y is not reducing y. Change in y. Yeah, y dot can be positive or negative, depending upon where you are. In that phase diagram, if you go back to yesterday's diagram, in some zones, y was required to come down to reach equilibrium. In some zones, y was required to go up. So the y dot can be negative or positive. The question is, when you're reaching equilibrium, the dy dot becomes smaller and smaller or not, you're reaching equilibrium. Number one point. Number two, when you reach equilibrium, y dot is 0. No more change in y is required. Y dot is dy dt, change in y over time. I'm going to run to your place, so I start running, and then when I'm reaching the destination, essentially I'm slowing down. That's what I'm saying. Otherwise, I will overshoot. Do you understand what I'm saying? Okay. So I start at a higher speed and then I slow down. Now, what's the assumption I'm making? Output would adjust to inventory signals that firms get whenever there's a disequilibrium in the goods market. Rate of interest would adjust, God knows why, don't ask me, I will try to explain, whenever there's a money market disequilibrium. Primarily banks would respond to that. That's the bank's behavior. Rate of interest is primarily the bank's domain, and money supply, demand for money is some ways in the monetary system. So maybe central bank does it or whoever does it. So now we will write two equations, find out whether it makes sense or not. Y dot means change in output is in response to disequilibrium in the goods market. So I can write an equation, y dot is equal to A y minus d, where A is the speed of adjustment is like less than 0. Why? Because if y is greater than d, you have a positive number here. What does it mean? Excess supply. Y greater than d means more output produced than demand. Excess supply, firms get unintended inventory changes as positive. They cannot sell it. So what they will do? They would reduce output. So y dot will be negative. So I make the coefficient A less than 0. When there is a positive number inside the bracket with a negative coefficient outside, y dot becomes a negative number, less than 0. Firms respond by lowering output level. But when they reach the equilibrium again, what will happen to y dot? When y is equal to d, What is y dot? 0. No more y changes are required. It's not a question of recession. It's not a question of expansion. It's a question of correction in the market. When you are off the equilibrium point, you are in the disequilibrium area, whether you reach equilibrium or not. It's not a question of recession or expansion or anything like that. All right? Okay. Similarly, I'm saying the rate of interest will adjust to a disequilibrium in the money market. So, my say M naught over P naught is the supply of money. I have the supply here, supply of output, minus demand for money, which you can put. What is the demand for money? I put an MD. Okay. So, it is MD over P naught, which is the demand for money function. Again, B is less than 0. When supply is greater than demand, rate of interest falls. When supply is greater than demand, rate of interest falls. Okay? When banks have enough cash, for instance, the demand for money is not so high. Why would banks pay a high interest rate to you? One explanation I am trying to give. They have enough cash. They don't have to attract your money through deposits, etc., by paying a higher interest rate. So, that acts as an incentive. So, when a rate of interest is like the price of money. So, if the money is enough there, supply of money more, rate of interest will be, can come down to adjust that. So, here again R dot is negative when you have B less than 0 and supply of money is greater than demand for money. Okay? Okay? Now, the problem is you have two differential equations. So, now I will set up the matrix. All I do is very simple. I have to rewrite this. Y dot is equal to A, here y minus D. What is D? Naught minus C into 1 minus Ty minus I function of R. This is the function you have, and your R naught is equal to B is M naught over P naught, and what is the demand for money? The demand for money is minus Hy minus LR. Okay? This theorem is not very complicated. If you want a reference, I can give it to you. I will keep some copy. If you are interested, write a mail to me at copy point. I will keep a proof of this theorem. It's not very difficult at all. So, now what I do, I totally differentiate this. Totally differentiate. What you have is dy dot is equal to A. Now, dy and here is a dy. So, it will be 1 minus C into 1 minus T dy, and dA naught is 0. I am assuming for stability purposes R and Y to change only. I do not want continuous shocks in the system. You never reach equilibrium. So, dA naught is 0. No exogenous variables are changing. So, you have minus, then you have minus IR dr. This is the first equation you have. Then you have dr dot, which is equal to B. Here M naught over P naught, supply of money is constant, is 0. So, what you have here is minus H dy minus LR dr. Now, what you see here on the right hand side, you have dy in both the equations, dr in both the equations. The simultaneous equation system is here. You have A coefficient. So, if you arrange them in matrix format, so in matrix format what it will be, in matrix format what will it be? A into 1 minus C and then A into minus IR, and in the second equation it will be minus BH and minus BLR. And it will be multiplied by this vector dy dr. All right. Now, what I was trying to tell you about this example here with one variable, essentially in case of one variable what you have, the second component is not there. The second line is not there, only this element is there. So, what you get as a second order condition is dy dot over dy is equal to this, whether that is negative or not. As dy changes, dy dot becomes smaller and smaller or not. As y changes, dy dot becomes smaller and smaller or not. That's the coefficient for one variable. For one variable, what you have is dy dot over dy, negative or not. You can see A is a negative term. In the bracket, you have a positive term, so it is negative. So, model is stable. But for two variable, I need that matrix. It can be easily shown mathematically. For two variable, you need that matrix. And what the stability conditions are twofold. There are two stability conditions. The stability conditions to one, determinant, which we often write as delta or something, should be positive, and B, trace of the matrix should be negative. Now, you check whether determinant is positive and trace negative or not. What is the determinant of that matrix? Determinant is how much? DET or capital D I have written, okay, capital D. AB minus AB LR, isn't it? Second bracket 1 minus C into 1 minus T. Then you have minus minus plus minus AB again HIR or something like that. This is what you have as a determinant. Right or wrong? Is it all right? Is it positive? It is. Very good news. Look, I have not assumed anything. Only thing I have assumed that output would adjust, which I have been saying right from the beginning, that when firms see unsold stocks piling in the godown, they would lower output. Unintended inventory changes are positive, increasing. गोडाउन का स्टॉक बढ़ रहा है, आउटपुट कम करो, तो कम तैयार करो, बाजार में बिक नहीं रहा है. That's the simple logic. And rate of interest is the one I added. When supply is more than demand, it's a simple demand and supply assumption, rate of interest would fall. Rate of interest is like a price in the money market. It's like a price in the money market, like price of money. If anybody asks you, what is the price of money? You can say it's rate of interest. Because if you hold money and don't put it in the bank, you lose that interest. So that's why in that negative inverse sense, it is price. It's like opportunity cost of holding money. So price of money is interest rate. You want to take a loan from the bank, money मांग रहा है, तो interest देना पड़ेगा. So price of money is like interest rate. So excess supply, excess demand, we already know. If there is excess supply, भाव गिरेगा क्योंकि companies cannot sell their goods, so they will lower the price. Simple. And if there is too much demand, like the housing sector I was talking about, if there is too much demand, then what do the builders do? They increase and increase. The owners of the houses, the rent and the price. Excess demand, price goes up. So that's the thing I'm saying. No big deal, nothing, all common sense. Some algebra, it looks like, my goodness, so much of things we are doing. It's not actually, it's very simple. All right? Okay. So this determinant is positive, you said? All right, very good. Is the trace negative? Trace is how much? the diagonal elements, sum of the diagonal elements. So it will be A 1 minus C into 1 minus T, and then plus minus B LR. Is this negative? It is negative, given the assumptions of the model. So having done all this, I sit quietly here saying we have a stable model in hand to deal with, the famous ISLM model. When ISLM, the paper was written, probably these conditions were not obtained. They were obtained later. I found them later, and I just make it a complete thing here by saying this is a stable model. Because now there are dynamic, kind of, in a static framework, kind of a dynamism is there in the background. Because shifts are taking place, two variables changing, we don't know in which direction the economy would go. Well, from the algebra, it's like a pathological test that doctors ask you, oh, a fever looks like you have a typhoid, but let's do a blood test. Ah, typhoid hi hai. Confirmed. This model looks like stable from the phase diagrams, but there is a possibility that oscillation can get bigger and bigger and diverge away. That is also possible. All right, it doesn't say everything that is going to hit the center, the intersection. So algebraically I test that like a laboratory test, and I say, okay, second order conditions are satisfied, the model is stable. It's a theoretical thing we do in economic theory, in models. We check the second order conditions. All right? As I was giving the example of optimum. Optimum can be maximum or minimum. But if you want to reach maximum, and to rule out that you haven't reached minimum, you check the second order condition. That's all. So the model is stable. I give you one example, you just think about it. What happens before I start the next part? Suppose I make a small change in the assumption. You will see how this model is vulnerable also to a small change. Suppose I make a small change, this model looks very nice, but suppose I make investment a function of rate of interest and output. I can do that, or income. As companies see more output is, more income is there, more demand is there, companies can produce more. Why not? It's just not the cost of borrowing money from the bank or R that determines how much investment, but investment can depend upon how much income the economy has generated. Like I'm going on a recovery path, more and more income is generated, not recession. Going on a recovery path, more and more output and income inspires the company to produce more because the demand is going up. That means. Similarly, in a recession, as the output is falling, the company gets a disincentive to invest when Y falls. Because अरे income output तो गिर रहा है. हर बार जब बाजार में सुन रहा हूँ, they go by news in the market a lot. And हर आदमी बता रहा है यार ये वो demand तो कम हो रहा है. The demand for goods are going down. उन लोग आउटपुट तैयार करना भी कम कर देंगे, इन्वेस्टमेंट भी कम करना शुरू कर देंगे क्योंकि इन्वेस्ट करके फंस जाएंगे. All this excess capacity and then they cannot sell it. This is true. This is how businessmen know. They don't live like on IIT campus and after teaching a course goes back to the residence or office, does some work and goes back. That has no touch in reality. Businessmen are the real economics. And this is how they do. They plan things. So investment, there is a valid reason for investment to be a function of output. Now, and a positive function. So what you have here is that IR is negative and IY is positive. All right? So now, when you work out the stability conditions, here minus IR था, here इधर में IRY हो जाएगा. And this differentiation will have minus IR dr minus IY dy. Another term will come. I give you a homework. Suppose you have this IY greater than 0 as an extra thing. You will see the second order conditions are violated immediately. So, this model is very vulnerable to even a small change which is quite realistic, like Iy greater than 0. Iy greater than 0, a small change, and the model is very vulnerable to that. Immediately you will see the stability conditions are disturbed. You don't know whether they are, theoretically speaking, model stable or not. It may not be. You can do that as an exercise, either in class or when you go back. Immediately. So, the model is restrictive, but is very popular, this ISLM model, and we often use the ISLM model to talk about various things. Do you understand what I am saying? In this condition here, when you work out, you just add this minus Iy dy, because I is a function of r and y, and you get the matrix, and then you get the stability conditions, determinant and trace. You will see, my goodness, और तो simple नहीं है. But in real life, our investment is a function of y, and in certain phases maybe of the economy, investment is more a function of y, say in the upswing. But then the problem is, an ISLM model, like, says it may or may not be stable. In real life, is it really so unstable? That's also the issue. The theoretical model may say it may become unstable, but in real life, is it really that unstable? These are very difficult questions to ask. I don't think no economy is that unstable. Though algebraically, theoretically speaking, the model can become unstable. You can check that yourself. The simple arithmetic you have to do there. I have the formula, everything written there. So, all you have to make I is a function of y again, in addition to r, and you will get a new result you will get. We need to do some comparative static exercises which are comparing two equilibrium points. When does it arrive? It arrives when these shocks are there to the system. Say government expenditure has increased, tax rates have changed because government decided to change tax rate, RBI decided to pump in more money, money supply increases. So, this kind of situations, we have a disturbance. So, in simple words, either the IS curve is disturbed or the LM curve is disturbed, so you require a new equilibrium. The question is, how far is the new equilibrium? So, we get into multipliers. All right. So, we are going to go into multipliers. So, let me do one by one. There are quite few, and there is a new multiplier that will come, the monetary policy multiplier. M changes, which wasn't there earlier. There was no money market in Keynesian cross model. Now, we have a money market. So, money supply can change. And the earlier multipliers, the two important ones, one was G change, the other one was tax rate change. Two multipliers we did. T, small t, G. Now we will add M and a few things. All right. Acha. So we would talk about these multipliers. All right. We'll talk about the multipliers. The first multiplier I would focus upon will be dy dg. So, if government expenditure changes, what will happen? This is the first multiplier. Now, algebraically speaking, we have y is equal to a naught plus c into 1 minus ty plus I r, and then m naught over p naught hy plus l r. These two equations. So, how do I get dy dg? I totally differentiate this, then substitute for dr from this equation, then dr is eliminated, and then I can get dy dg. So, you totally differentiate this. What you have is dy. In a naught, I am going to make one variable change, g. nothing else. So, I will have dg plus c into 1 minus t dy plus ir dr. From the second equation, m naught over p naught is 0, is a constant. So, I have 0 is equal to h dy plus lr dr. Now, you can see from dr, from this second equation you can solve dr. dr will be minus h dy over lr, which you can substitute here for dr. dr gone. Then I can solve for dy dg, right? Am I making any sense? Is it all right? dy dg, you can see from the second equation, you can get dr is equal to minus h dy over lr. You substitute here. So, what you get if you do that, then dy becomes dg plus c into 1 minus t dy plus ir into here ir, it will be minus h over lr dy, ir into minus h over lr into dy. Am I correct or not? Then, if you arrange terms dy into 1 minus c plus h, a whole bunch of terms will dy will come on the left hand side and dg there. So, this will give you this multiplier dy over dg 1 over 1 minus c into 1 minus t plus 1 minus c into 1 minus t plus IR H over LR. This is the multiplier you will get, right? Now, so this is the multiplier, and what was the earlier multiplier? You didn't have this bunch of term, isn't it? It was 1 over 1 minus c into 1 minus t. But this bunch has come. You can see what are the parameters: investment function, IR, liquidity preference curve or speculative demand for money, LR, H was there, all right? Okay. So, this is the multiplier. Now, you can see one thing, IR is negative, LR is negative sign. So, that becomes positive into H. So, essentially this is a plus term. This term is a plus term. This term is a plus term greater than 0, all right. This is greater than 0, this one. So, has the multiplier become stronger or weaker? My goodness. Weaker, plus term in the denominator, the strength has fallen. So, what you notice is the government expenditure multiplier is becoming weaker and weaker the more realistic we are making the macro model. In the first macro model, when government expenditure multiplier came as autonomous expenditure multiplier or government expenditure multiplier, in the Keynesian cross model without taxes, it was simple 1 over 1 minus c. When taxes came, proportional tax system, it became 1 over 1 minus c into 1 minus t. Multiplier is bigger. Now, I bring in the money market and the investment function, two things in the ISLM model, it has become more weak. So, it is a huge problem. The expenditure multiplier is becoming weaker and weaker. Now, let me talk about why is it weaker. Then, we will go over to various aspects of this multiplier. At a diagram, you understand what is happening. Let us look up at the diagram. Okay. Now, this is the ISLM diagram. Rate of interest. This is IS curve, this is LM curve. This is the initial equilibrium point. Say these are the initial equilibrium points, Y naught, R naught. Now what you are saying, government expenditure has increased. So IS curve would be shifting to the right. So the IS curve has become this yellow line, call that IS1, and call these initial lines IS0 and LM0. So the economy has moved from one equilibrium point to another equilibrium point. Economy has moved from one equilibrium point to another equilibrium point, and output has increased to Y1, but rate of interest has also increased to R1. Output has increased to Y1 and rate of interest has also increased to Y1. All right? Okay? And you are saying, sir, the multiplier has become weaker. You can see a bunch of terms here. Now, I can see one thing. If IR is 0, investment doesn't respond to R, this whole bunch of term will disappear. But if IR is 0, then I have the old multiplier 1 over 1 minus C into 1 minus T. But IR 0 means what? If IR is 0, it implies that the IS slope of IS has also changed, which was how much? 1 minus C into 1 minus T over IR. Here the slope of IS, if you check. So if IR is 0, what happens to the slope? IS becomes vertical. The IS curve becomes vertical. And vertically it shifts. All right? So the IS curve, when it vertically shifts, you have a multiplier which is ignoring this part which entered through the money market, etc., and the ISLM model, and you have the old multiplier. This is number 1. So the multiplier becomes stronger. So the thing is, IR, this seems to be a very critical parameter which makes investment expenditure multiplier, government expenditure multiplier weaker. What is the weakness? The weakness is as follows. Why it has become weaker? As output increases, all right, as output increases slowly, धीरे धीरे increase करते हैं, you are off the money market, LM curve. Let's assume the money market adjusts quickly, rate of interest adjustments are quick. So a little bit of increase in output increases the transaction demand for money, and when the transaction demand for money increases, so demand for money is more than supply of money, so rate of interest would increase. When demand is more than supply, price rises, so rate of interest would increase. So the rate of interest will increase and you climb up to the LM curve. Again, since the demand is more, again output increases a little bit. Companies are adjusting. Demand has gone up to there. So it happens and the rate of interest again increases to clear the money market. So LM का equilibrium को maintain करते करते जब भी disequilibrium जा रहा है, output भी economy में थोड़ा थोड़ा increase होते जा रहा है. Suppose, but as rate of interest is going up, what is happening here, as R increases, I can put it here, as R increases to clear the money market, as R increases to clear the money market, private investment I falls in the economy. R and I are inversely related. So demand for goods are also falling from IR side, although there has been an initial increase in demand for goods from G. G has pulled up demand for goods. Companies are producing more because there is more demand, but there is a negative thing going on in the economy. Slowly it starts happening that the rate of interest starts increasing, which affects, according to our assumptions, private investment. So one component of demand starts falling, private investment, whereas the government component of expenditure goes up. So this stepwise, you may be reaching equilibrium to the new equilibrium. Through clearance of the money market, you keep on clearing the money market via rate of interest adjustments when output in the economy starts slowly increasing in response to extra demand. But the extra demand from G that has come through this variable is now countered by a shrinkage in demand through falling I. Why does falling I happens? Because rate of interest increases, so I falls. So what you notice therefore, that as G increases, government starts increasing more expenditure, pumps in more money, infrastructure projects, roads, highways, bridges, etc. If rate of interest starts increasing, private investment starts shrinking. So it is like government is increasing its expenditure and trying to improve the economy at the cost of private investment. So there is a battle going on between you government and me private investment. आप ज़्यादा काम करेंगे, मेरा काम कम हो रहा है. मैं ज़्यादा काम करूँगा, आपका काम कम हो जाएगा. It's a tussle going on. All right? Because of this negative impact, the multiplier, the meaning of the multiplier is because of the negative impact on private investment that the multiplier has become weaker. The net effect on increase in output is becoming smaller, not that much. क्योंकि कोई उसको पीछे पकड़ के भी रख रहा है. गवर्नमेंट इसमें उनको भगा रहा है सामने, borrow output income, private investment expenditure shrinkages, reductions are lowering it. All right? This is what is coming out as a message from the model. And therefore, what you see here, the multiplier in algebraic terms, that it has become weaker, which I told you right in the beginning when I obtained the multiplier for you on board, that this has become weaker, it means that why it is weak. Now, this weakness will go as soon as investment is not a function of interest rate. You can see that. If IR is 0, R changes don't affect I. You can see that from the algebra here. If IR is 0, what happens to the multiplier? It becomes the older multiplier. All right? Then there is no negative impact on private investment, only government expenditure. IR is 0 essentially means IS is vertical. So the IS curve will be vertical here, and when IS increases, you get a new level of output, whatever that increase in IS is. This much, if you go, it will be somewhere here, which is the same way as saying if rate of interest doesn't change, if R doesn't change, dr is equal to 0, what happens? If dr is equal to 0, if dr is equal to 0, dy is equal to dy dg is 1 over 1 minus t into 1 minus t, and here dr is equal to 0, essentially you have a dy value which is solved from the first equation, right? dr is equal to 0. If rate of interest doesn't change, you get the same result which I am trying to talk about, earlier result. dr is equal to 0 means the multiplier will not have these components. It will be 1 over 1 minus t into 1 minus t, which is essentially what I am saying is if dr is equal to 0, if I use a color chalk, then R doesn't change, means I go from here to here. The economy moves from here to here, and you get an output level which is y prime 1. This output level y prime 1, the dy, this dy or delta y, whatever you call that, this dy is essentially 1 over 1 minus c into 1 minus t into dg. That means dy over dg is 1 over 1 minus c into 1 minus t. Okay? But this fellow here, this little bit of increase is our multiplier, this fellow here. It will be dy over 1 minus into 1 multiply IR HLR into dg. Smaller impact on output. The larger impact on output would be this if rate of interest doesn't change, which is the same thing as I'm saying that investment doesn't respond to rate of interest change. Same thing. So the disturbing story here, for therefore message coming out, that with taxes you have created leakages in the system where increase in output and income cannot be enjoyed by the households so much because government takes away tax revenue. Now with the money market and investment being sensitive to rate of interest changes, you have created another very negative thing, which is realistic maybe. Government anytime wants to increase output or expenditure by spending more, G increase, doesn't have a good impact because it is dampened by private investment reduction. The reason is rate of interest would increase. So if private investment doesn't reduce, then it is all right. It doesn't fall. This private investment reduction that IR falls as G increases, I falls, this famous message is known as crowding out effect. Crowding out effect of expansionary government expenditure. Expansionary government expenditure policy. This crowding out effect is a very important thing, that the private investment is crowded out. So what I'm saying, suppose this room is full of students. Now if I invite Kanpur University students, there will be a crowding out effect. As those people come, some of our IIT Kanpur students will have to leave the room because there is no space for them. So crowding out effect of inviting Kanpur University students to my macro course on IIT Kanpur students. As government is trying to push into the economy and starts doing things, the private investment gets a dampener. It's discouraged. It falls. This is very important result, the crowding out effect, which in parametric terms is essentially is IR. If you make IR 0 somehow, either investment not responsive to interest rate or interest rate doesn't change, R is constant as I done with the pink line here, then no crowding out effect. Even if IR is not 0, DR is 0. Two ways you can do it. IR is 0 or DR is 0. If DR is 0, government restricts in interest rate, there won't be any crowding out because interest rate is not changing. How can investment respond? Or investment is not responsive to rate of interest changes, even if government allows rate of interest to be free, interest rate investment doesn't change, and therefore you will have no leakages. Otherwise, you have this thing coming out. It's a very important result. Is that clear to you a little bit? Has it been clear? Okay? Now, I would like to talk about a few more things. In this model, what will be the tax rate multiplier? You tell me, you people tell me what will be the tax rate multiplier, dy dt. dy dt, what will it be? The dy dt multiplier in this model. So from the first equation, I's equation, what you have is dy, no dg term, 0, c into 1 minus t dy minus c y dt plus IR dr. From the second equation, LM equation, what you have is 0 is equal to h dy plus LR dr. Again, you get the dr value from here, you substitute it there. So what essentially you will have, if you club terms, is that you will get dy over dt is equal to minus cy divided by 1 minus c into 1 minus t plus IR h over LR. IR h over LR. But the problem you remains, what is the value of y and what is the value of t here? There are two y values, two t values now. You remember we did a substitution method for the Keynesian cross model tax multiplier. This y will be y naught, initial y, and this t will be the later t, post change t. So this multiplier, if you write with the proper notations, will be minus c into y naught divided by 1 minus c into 1 minus t1 plus IR h over LR. This is the multiplier. Okay? Now, if a tax rate cut is there, how would the equilibrium diagram show? Can anybody have any idea? If taxes are cut, ISLM diagram, how will it look like? If taxes are cut, what will be the effect in the ISLM diagram? Yes. Slope changes are there. So which curve? LM or IS? IS. So it will become steeper or flatter? Taxes are cut, reduced. Cut means reduced. Look at the slope of the IS. The IS curve will become steeper or flatter if taxes are cut. If taxes are cut, will IS curve become steeper or flatter? Flatter, right. So the diagram will be, I can draw a small diagram here. What you have here is the following. This is the IS, say IS naught. This is the LM, LM naught. And then if there is a tax cut, then the IS curve will become flatter to IS1. So you reach a new equilibrium point where a higher output is there, and you can have the higher output y naught, and the tax cut here will be y1. In this case also we can see that the rate of interest will increase from R naught to R1. There will be some crowding out effect. There will be some crowding out effect because rate of interest increases. Without increase, because the tax cut multiplied in the Keynesian cross model didn't have IR h over LR. So you can see the multiplier has become weaker. Both ways it has become weaker. Tax increase, tax cut. So it was only Cy naught over 1 minus C into 1 minus T1. Now plus IR h over LR is there. So there is some crowding out also here in case of a tax cut policy. Now before I go further, let me tell you, because you are new students of economics and you don't pay attention to economics, that's the way I don't pay attention to all that is happening in physics, chemistry, and mathematics, and who knows, all these engineering disciplines. We are very popular with, we are very used to with these terms. The discussion that I had so far comes under something called fiscal policy of the government. So government's fiscal policy is the finance ministry's job. And the finance minister like Mr. Pranab Mukherjee will be doing, and I have been busy with, fiscal policy. Finance ministry does that. So the fiscal policy I have talked about, one, the G policy, the other one is the tax rate policy. So, two fiscal policy I have talked about today, which I did earlier also, but the heading is called fiscal policy. All right. Now, I have talked about dy/dg, I have talked about dy/dt. These are common two fiscal policy instruments, G and T, which are used for fiscal policy purposes. Suppose the economy is going up, all right, earning a lot, so that it doesn't climb up too quickly like a very overexcited child who starts jumping on the bed, doesn't realize the ceiling is very low and hit the ceiling, all right, and has an injury, then hospitalized. So, in a business cycle economies, finance ministers have this job. If the economy is on a recovery path, if it's going up too quickly, like a bubble, etc., they were asking me in the break, so that there is no much bubble, false kind of an impression, an expectation that the economy is doing too well. So, it can try to check that, the movement, through what you can call contractionary fiscal policy. The contractionary fiscal policy will be reduce G, increases or increase taxes. So, people don't overspend. They spend, but taxes are also collected. So, the multipliers are becoming weaker. All right? You reduce the economy, counter-cyclical policies. So, fiscal policy can be used as counter-cyclical policy, एक साइकिल जा रहा है ऊपर, उसको नीचे, उसको रोक रहा हूं, उसका स्पीड काउंटर कर रहा हूं, trying to prevent it to run so quickly, countering the speed, all right, putting a barrier, putting a hurdle. So, counter cyclical policy can be used with this fiscal policy, all right. They can all be used as a counter cyclical policy. So, in case of a recovery, what will be the case? G will be used. So, the output shrinkage is there a little bit, although the private sector output is growing too quickly, and taxes can be increased. So, IS can be made steeper and restrict output increases. These are all counter cyclical policies that can be used by the finance minister. Now, in a recession, what counter cyclical policies finance minister should use in a recession today in India, according to this kind of a fiscal policy issue that we are discussing? What should be the ideal counter policy prescription for the government based on this limited knowledge that you have? In recession, reduce. You need, already output is reducing, you need expansion in government expenditure to boost demand, and you require tax cuts so that people spend more. The counter cyclical policy in recession would be just the opposite, increase G, reduce T. In a boom time, you require reduce G, increase T. So, the counter cyclical policies that one would require. But this has other consequences, I am not going to talk about that now, but the common sense says in the ISLM framework that the counter cyclical policies that the finance minister should adopt in a current environment is where there is a recession, output is falling, demand is falling, all right, is to increase G and lower T, all right. So, people spend more. If they lower my taxes, the income I get from IIT when I go home, I can spend more. Spend more means I buy goods, and the companies see more demand is there for their goods. So, they would produce more, there will be more income generated, multiplier will operate in a positive direction, more employment, etc. This kind of a counter cyclical policy will have. So, fiscal policy is one. The one I need to add, which I will bring in today, but I will conclude it tomorrow, and that will be the last thing that is very important. Now, money market and government can pump in more money. How will it pump in more money? There are various ways. One, in a country like India, there is something called cash reserve ratio. What is a cash reserve ratio? CRR. I am going to talk about monetary policy. Next, I am going to talk about monetary policy, and I am going to talk about one monetary policy. There can be various kinds of monetary policies. Usually there are twofold. One is to affect M, and another one is to affect R. I'm going to talk about the monetary policy. M, how it can be increased if government wants to increase it. There is something called CRR, the simplest example that I can give you. Something called CRR. Something called CRR. This is called cash reserve ratio. When banks accept deposits from us, from the public, deposits go where? They go into savings accounts, fixed deposit accounts, current accounts, various accounts bank has, where we open accounts and money goes there. These are called, from bank's point of view, commercial banks I'm talking about. Bank's point of view, these are deposits, public money, public deposits. Since it is public money, government has made rules, which started in fact after 1930s, that the central bank says you have to keep a cash reserve ratio with us. What does it mean? That these deposits, you don't have entire freedom to use them for loan purposes, for any other investment purposes. You don't have enough freedom. A part of that cash, every week on Friday, you will have to tell us how much deposits you have, and given the CRR percentage number, 7%, 8%, whatever, 8% of that cash, 7% of that cash, you will have to deposit with us. Literally cash from bank goes to RBI office and in a locker. State Bank CRR, Bank of Baroda's CRR, Canara Bank CRR, Punjab National Bank CRR, सब जाते हैं उधर. Every Friday, cash reserve ratio. That money stays there and gets on adjusting on CRR and deposits. ठीक है? अगले हफ्ता डिपॉजिट और बढ़ गया तो एक्स्ट्रा जितना हुआ उतना CRR पिन डाल दो, क्योंकि पिछले हफ्ते से तो some CRR is already there. All right? Okay. Now, the CRR money is essentially a precautionary money. In case banks mismanage the money that they collected from the depositors by giving out too many loans, by giving out bad loans, where the money was not returned, खा गया, कोई politician आके, दादा आके, हमको 10 करोड़ का लोन दे दो, वो बेकार चला गया लोन, इलेक्शन पर्पस में व्यवहार हुआ, कोई प्रोडक्टिव पर्पस नहीं, लेकिन वो पाड़ा का दादा था, इंडिया में जो होता है, रुपया लेके चला गया, MP, MLA, बैंक डर के बजाय से रुपया मांगे भी नहीं, पूरा 10 करोड़ खा गया, कोई रिटर्न नहीं हुआ, called bad loans. In formal language, banks call them non-performing assets. To banks, loans are like assets, because on loans they make money. Dada liya ki bhai liya, it is not important. So these assets have become non-performing assets, means the loans have not been returned, interest payment to हुआ ही नहीं. They are called bad loans also. Now, but that money was giving out of the deposits of you and me. So tomorrow when we go and if the bank says, sorry bhai, आपका रुपया तो है नहीं, हो गया तो. मेरा तो life खत्म. सब savings उधर ही था. It happens. Bank is closed or something. So the central bank keeps CRR money. Then the central bank डांटते हैं, उनका ही रुपया CRR से निकाल के जितना bad loan हुआ है दे देते हैं. It can be used, that cash, to bail out the bank. And then of course they start some monitoring, more serious, sincere monitoring of the bank, what the bank is doing. Maybe the bank manager is a corrupt, is a nephew of that dada, or a friend of dada. All right? So these dadagiris go on in India. Once upon a time I heard that the largest defaulters means who took a loan, didn't return the money to banks, are the big companies. I felt extremely good. India is on the right path. The largest defaulters are not the small borrowers, are the large borrowers, who got the big companies, who had the more say, who make more money. That means they deliberately defaulted. All right? And government even cannot do anything about it. The system is so corrupt, the government even doesn't do anything about it. All right. So these are data available. These are not jokes I'm saying. It's just not cooked up story I'm telling you. This is actual numbers I'm talking about. The largest defaulters in Indian banks are the big companies. Now then you have the farmers' issues, etc. You know that they borrow money, they eat up their capital, there's no monsoon, they cannot produce anything, and the harvest goes and they lose everything. So what I'm trying to say is that the monetary policy can operate through CRR where money supply can increase. So now if RBI reduces CRR number, what will happen with banks? More money, they can give out more loans, more money will be inside the economy again, pumped, CRR. So this is one simple way I'm talking about, one simple route through which money supply can affect the economy. So suppose money supply increases, we can talk about a simple monetary policy in this multiplier. What will happen now to dy dm, say? So we can get the algebra done. This is the last thing we will do today, dy dm. A little bit of monetary policy. Now I'm going to talk about monetary policy. And it's a very simple monetary policy. It can be much more complex. The monetary policy I'm going to talk about is dy dm. How much is it? Now you can work that out. Is function is IR, and this is m naught over p naught is equal to hy plus LR. Now if you do the algebra here, the first equation will give you dy is equal to dA naught is 0 now. I'm talking about monetary policy. No g increases. Is c into 1 minus t dy plus IR dr. The second equation will have dm over p naught, because monetary policy, money supply is increasing, dm or decreasing, whatever. Increasing or decreasing, dm means it can be positive or negative. So dm over p naught is equal to h dy plus LR dr. Okay? Now you need to substitute for dr. So you can get the dr number from here, which is dm over p naught minus h dy over LR. So what you have from the second equation is dr is equal to dm over p naught minus h dy divided by LR, right? That's what you have. dr is dm over p naught minus h dy over LR. Now substitute that there. Therefore dy in the is function will be c into 1 minus t dy 1 minus t dy plus IR over LR into this bracketed term, this entire bracketed term, dm over p naught minus h dy, which means what you have there is a dy term that will come minus h dy with IR, LR, h dy will go. What you have here into minus this term c into 1 minus t plus IR h over LR is equal to, now you have dm p naught here into IR over LR. So you have IR over LR dm over p naught. So what you have dy over dm is, in the numerator you have IR over LR and into p naught. P naught can come downstairs. So you have p naught into 1 minus c into 1 minus t plus IR h over LR. IR LR over p naught into 1 minus c into 1 minus c plus IR h over LR, this one. Clear? Now, can you sign this? Is a positive multiplier or a negative multiplier? Denominator is positive, the numerator is positive. So, it's a positive multiplier. Okay. So, in very simple words, what you have is, this is a diagram that we require. Very simple words, what you have is, you have an ISLM diagram, YR, you have IS curve, IS naught, you have LM curve. Now, money supply is increased in the economy, so it will shift parallelly to the right. So, you have LM1, it will shift parallelly to the right, LM1, and what you have is output in the economy will increase Y0 to Y1, and the rate of interest will also, no, the rate of interest will fall. Rate of interest will fall. Now, the question is this IR over LR into P0, whether this term is greater than 1 or not. If it is a greater than 1 term, then this multiplier is stronger than the dy dg, because dy dg you had only this bracket term, third bracket. Now, the terms are IR over LR into P0. All right. If this is strong, you can say that if IR over LR into P0, if this term is greater than 1, then you can conclude that dy dm will be bigger than dy or greater than dy dg. This is easily good. This is an important conclusion, that a monetary policy can be more effective than government expenditure policy. Monetary policy can be more effective than government expenditure policy, provided IR over LR P0, this parameter value is greater than 1. If it is equal to 1, two multipliers are same. If it is less than 1, then monetary policy is less effective than government policy. So, you can put a few more properties here, equal to, less than 1, you can put it this way, will be equal to, less than dy dg. I can do that, nobody stops me. I can compare the expansionary fiscal policy with expansionary monetary policy. Expansionary means increasing, contractionary means decreasing fiscal policy. So, I can compare them. An expansionary fiscal policy, kaun sa acha hoga for India? To do that, to judge that, I need the parameter values, whether to use G or whether to use M. Because one good thing is happening here, we can see with M increase, rate of interest falls, no crowding out. So, there is no negative impact on government, on private investment. But if you have expansionary government expenditure policy where IS shifts upwards, rightwards, rate of interest will go up because LM is upward sloping. So, rate of interest will go up, and rate of interest going up means private investment is crowded out. Bad news. But with expansionary monetary policy, there is no crowding out. In fact, it helps private investment more because rate of interest falls and more private investment activities. So, the transmission channel of output increase for money supply increase is essentially this, because when money supply increases, banks can lower the interest rate, give more loans, because bank has more cash, more loans to companies. So, companies can come and take more loans at a lower interest rate and invest more output is produced. Opposite of crowding out. This is how monetary policy is working. Why is M increasing output? You have to ask this question. Diagrammatically, M increase means LM shifting, new equilibrium, output increase. But why? What's the intuition? Because M increase means banks have more cash. Government, RBI has lowered the CRR. Now, banks have to do something with the cash. So, they lower the interest rate and tell companies, now come, we are going to give you more loans. Companies are attracted by lower interest cost, they take more loans, more private investment, so more output. So, some people may argue the expansionary monetary policy is perhaps a better counter-cyclical policy when you are coming out of recession than expansionary government expenditure policy. So you can tell the finance minister, sir, humbly you can tell him, he knows so much, sir, which one will be better? Now you know this. More government expenditure policy or expansionary monetary policy? Economy is in recession, which one will be better? Because you have some model here which you can use. Do you see why I am teaching this? You learn some practical things. Some of you will enjoy this at some point. Most of you will forget. Now you have other courses to do, your department courses, your major subjects, civil engineering, chemical engineering, metallurgy, so many things. But this has a practical side, what I am trying to say. Is that okay for today? Enough for today. But I will continue this tomorrow.